Hi guys, last week we were using bar models to help us analyse and solve multiplication problems. This week we're moving on to fractions and we're going to be using bar models to help us add fractions. To begin with, let's get thinking. I'd like you to think about what this word fraction actually means. I want you to pause the video for a couple of minutes, discuss your thoughts with a partner and then share with the rest of the class. Very often when we think about fractions, we think of this representation of them. And when asked, what does that say? Quite often people will say things like 1 over 2, or 1 over 3, or 3 over 5, and so on. But I don't want us to think of fractions like this just at the moment. I want to think, what do fractions actually look like? So I want you to think of a visual representation of our fractions. So more like these, where we can see we've got 3/4 of a bar of chocolate, we've got half a pizza, we've got a third of a bar, we've got an eighth of a bar, we've got a shape cut into 5 parts, and we've coloured 3 of those parts. I'd like you to consider the following statements and decide whether you think they're sometimes true, always true, or never true. Fractions are smaller than a whole, and a half is bigger than a third. So pause the video for 2 to 3 minutes, consider your thoughts, and share those with the class. Let's consider that first statement. Fractions are smaller than a whole. Here we've got 1/2 pizza and we've also got 1 whole pizza. And often we think of that 1/2 as it's written using digits, with the numerator at the top, in this case 1, and the denominator at the bottom, in this case 2. Where the denominator tells us how many parts the whole has been split into, so it helps us name the fraction. And the numerator at the top tells us the number of parts that we've actually got. So here the 2 tells us that we're dealing with halves, whereas the 1 tells us that we've only got one of those halves. Now we can see that in this case 1/2 pizza is smaller than 1 whole pizza, so surely we can say that it's always true. Fractions are always smaller than a whole. Well, let's consider another fraction. This time we've got 5 halves. We're dealing with halves, so the denominator must be 2, and we've got 5 of those halves, so the numerator must be 5. Here we can see that 5/2 pizzas is a lot more than 1 whole pizza, so the fraction is actually larger than 1 whole. If we're talking about unit fractions, where the numerator is 1, like 1/3, 1/2, 1/4, and so on, then the fraction is always going to be smaller than the whole. However, we can have any number of that fraction. We can have 2 halves or 3 halves, or in this case we've got 5 halves. So a fraction can actually be bigger than a whole. So in this case, I'm saying the statement is only sometimes true. Let's consider the next statement. A half is bigger than a third. So here we can see we've got a bar of chocolate, and if I said you can have half a bar of chocolate or a third of a bar of chocolate, we can see that 1/2 is bigger than a third of a bar. So again, surely it's always true that a half is bigger than a third. However, instead of having that 1 bar of chocolate, let's just say that we've got those 2 bars of chocolate there. If I offered you a half of the first bar or a third of the second bar, then we can see in this instance that actually a third of the larger bar is bigger than half of the smaller bar. So here a third is actually bigger than the half. So again, it's sometimes true. The size of the fraction depends on the size of the whole amount. Now I'd like you to consider the following 3 statements and decide whether you agree or disagree with them. Here we've got Peter, and he's saying that he's cut the chocolate bar into 4 parts. I've made quarters. Gamora is saying I have cut the pizza into 8 parts. I have made eighths. Rocket is saying I've cut the gold into 6 parts. I have made sixths. So again, I'd like you to pause the video for a couple of minutes and decide whether you agree or disagree with each of their statements. And remember, I'd like you to justify and give reasons. Let's consider each of these statements in turn. So to begin with, let's look at Peter. I have cut the chocolate bar into 4 parts. I have made quarters. Well, he split that into 4 parts, but 2 of those parts are rectangular and 2 of them are triangular. So surely they can't be the same. Well, actually, there's exactly the same amount of chocolate in each of those parts. So I would agree with Peter, yes, he's cut those into quarters. What about Gamora? And Gamora is saying, I have cut the pizza into 8 parts, I have made 8. Well, yes, she has cut that pizza into 8 parts, but those parts aren't the same size, they're not equal. So therefore, Gamora has not made 8, so we're going to disagree with her here. And finally, let's have a look at Rocket. I have cut the gold into 6 parts, I have made 6. Once again, he has cut that gold into 6 parts, but we can see we've got different shapes there. However, each of those parts are exactly the same size. So again, I agree that Rocket has cut those into 6. For those of you who've still got your doubts, let's take Peter's chocolate bar. He cut that into 4 parts, as we can see there. Now let's take 2 of those different shaped parts, and those parts are exactly the same size. Now if you don't believe me, let's take that triangular piece of chocolate. Let's split that there. Let's turn that round and move that down so you can see it's exactly the same size. I didn't take any chocolate away, I didn't add any chocolate. I simply cut that into 2 smaller parts that I moved together to form exactly the same shape and size as the rectangular piece of chocolate. And let's have a look at Rocket's gold. Once again, he cut that into 6 parts, as you can see there. Let's look at 2 of those different shaped parts. And when we split that long rectangle into 3 parts, we can move each of those parts together. And once again, you can see that they are exactly the same size. So what this tells us is that the shape of the part is not important when it comes to fractions. What's important is that they're the same size. I'd like you to consider the following. Drax and Mantis each start with a piece of paper. Drax folds his piece of paper in half, then he halves it again, and finally a 4th time. What fraction of the original piece of paper are each of the parts that he's created? And Mantis folds her piece of paper into 3 equal parts. She then folds it into 3 equal parts again, and I want to know what fraction of the original piece of paper are each of the parts that she's created. So pause the video for a couple of minutes and discuss your thoughts. Let's consider what Drax does to begin with. He takes his piece of paper and he folds it in half. So there we can see we've got half. He then takes that and he folds it in half again. So we've now got this. He folds that in half again. So we've now got this. And he folds that in half again. So we've now got that. Now when we unfold that paper, what do we have? We can see there that we've got 16 equal parts, so each of those parts is 1/16 of the original piece of paper. Let's consider what Mantis does with her piece of paper. She folds it into 3 equal parts, so let's split that into 3 parts, as you can see there. Then she folds that into 3 parts again. So let's do that, and we're left with this small piece of paper here. Now, when we unfold the paper, we can see that that whole piece has been split into 9 equal parts, so we can call each of those parts 1/9. They're exactly 1/9 the size of the original piece of paper. It's time to get investigating with a partner. Here we've got Peter and Gamora, and they each started with a whole bar of chocolate, however they've eaten some. Peter eats some chocolate and has half a bar left. Gamora eats some of her chocolate and has a quarter of a bar left, and they're trying to work out how much chocolate they've got altogether. Can you help them? Now Peter's saying, I think we've got 2 halves altogether. Gamora's saying, no, I think we've got 2 quarters altogether. And Drax is saying, you're both wrong. A half plus a quarter is 2/6. Look, and you can see there, he's performed a calculation where he's added 1/2 plus 1/4 to get 2/6. Once you've had a go at that, I want you to consider the following. What if Peter had half a bar and Gamora had 1/3 of a bar of chocolate? How much would they have altogether in that case? As with previous weeks, I don't want you just to come up with an answer, I want you to solve it using resources. You may want to use A4 paper, post-its, strips of paper, or you might have fraction cards available to you. Then I want you to explain your solution using pictures and diagrams. So pause the video for 8 to 10 minutes and have a go at that with a partner. Let's consider each of their thoughts in turn. Let's start with Peter. And Peter said, I think we have two halves altogether. So if we take the half bar that he's got and Gamora's quarter bar, if we add them together, we can see clearly that that's less than two halves. So I'm afraid in this instance, Peter is wrong. What about Gamora's thoughts? Gamora thought that they have 2/4 altogether. And once again, we can see if we take Peter's half bar and her quarter bar, if we add those together, in this case, that's more than 2/4 bars of chocolate. So I'm afraid she's also wrong. Let's consider Drax's thoughts. He thought that a half plus a quarter is 2/6. So let's have a look. Now to do this, we're going to use fraction cards to help us. So there we've got a whole, and if we split that into two parts, we've made halves. So we can see that each of those is 1/2. Let's take the whole again, and this time we're going to split it into quarters. There's our 4/4, so each of those parts is 1/4. And finally, let's take the whole again, split it into 6 parts, so each of those parts is 1/6. Now if we use these to help us, we'll be able to see whether we agree or disagree with Drax. So let's take 1/2 and 1/4. Is that the same as 2/6? Well, we can see quite clearly that the 2/6 are nowhere near as big as the half and the quarter together. So unfortunately, Drax is also wrong. Why did Drax make that mistake? Well, he simply added the two numerators to get 2, then he added the two denominators to get 6, and it can be quite easy to make that mistake when we just think of fractions using that fractional notation with one number over another. That's why it's so important to think of fractions visually. It's not only going to help us understand how to add fractions, it's going to help us multiply, divide, and solve much more complex fraction problems in the future. Let's use those fraction cards to help us work this out. Let's take the half and the quarter that Peter and Gamora start with. We can see there that we've got two different fractions there. We're trying to add 1/2 and 1/4, and at the moment they're not the same. So we can't say they're 2 halves, we can't say they're 2/4, we certainly can't say they're 2/6. So what are we going to do here? Well, we can take that half and we can split that in half itself. Now when we do that, we make 2/4. Now we've got 2/4 plus 1/4. They're all the same. 2/4 plus 1/4 gives us 3/4 altogether. So 1/2 bar of chocolate plus 1/4 of a bar of chocolate is 3/4 of a bar altogether. Now we used equivalence there to help us. We couldn't add the half and the quarter as we were, but we found a fraction that was equal to the half. 2/4 is equal to 1/2. Once we had 2/4 plus 1/4, we could add them together. Let's consider the second problem. What if Peter had half a bar and Gamora had a third of a bar? Now this time I'm going to use a bar model to help us. Let's start with Peter's 1/2 of a bar. And we're trying to add 1/3 of a bar. Now we can see those two parts are different. I cannot add them together. I can't say I've got 2 halves there, I can't say I've got 2/3, and I certainly can't say I've got 2/5. So what can we do? We can find fractions that are equal to 1/2 and 1/3. Why don't we take our half bar of chocolate and split each of those halves into 3 parts? Now what we've actually done is split that whole bar into 6 equal parts, but we didn't have the whole bar, we only had half a bar. So therefore 3 of those 6 is the same as 1/2. Let's take the third of a bar that Gamora has, and this time why don't we take each of those thirds and split them in half? Now once we do that, we've created sixths again. The whole bar of chocolate has been split into 6 equal parts. However, she didn't have the whole bar, she only had 1/3. And that 1/3 is exactly the same as 2 of those sixths. So we've now got 3/6, which is the same as the half bar, and 2/6, which is the same as the third of a bar. Now we can add them together, and 3/6 plus 2/6 gives us 5/6 altogether. Once again, we've used equivalence. We've converted those fractions into fractions that are the same, Once they're the same, then we can add them together easily. It's time to discuss our success criteria. So once again, I'd like you to pause the video for a couple of minutes, and with a partner, I'd like you to discuss how did we achieve success? What are the steps that we need to go through in order to add any fractions? So how do we successfully add fractions together? Well, to begin with, we have to ask ourselves a question. Are the fractions the same type? And if the answer to that is yes, so in this case we've got 3/4 plus 2/4, then we can simply add the fractions together to get 5/4. What if the answer to that question was no? What if they're not the same fraction type? Well, here we can ask ourselves another question. Can I use equivalence to change one fraction type into another? So here I've got 1/2 and I'm trying to add 1/4. Can I convert halves into quarters or quarters into halves? Well, yes, I can convert that half into 2/4. So if that's the case, I can convert that fraction, and once I've got 2/4 plus 1/4, I can add the fractions together. But what if I can't use equivalence to change just one of the fractions? Here I've got 1/2 plus 1/3. Now I can't convert halves into thirds, and I can't convert thirds into halves. So if that's the case, then we need to convert both of those fractions. I can split that half into 3 parts to make sixths. I can split that third into 2 parts to make sixths. Once I've done that, I've got the same type of fraction. I can then add those fractions together. So I've got 3/6 plus 2/6, which gives us 5/6. It's time for you to try that out. Each of the Guardians started with a full bar of chocolate. However, once again, they've eaten some of that bar. Rocket has 1/2 bar left. Peter has 3/4 of a bar left. Groot has 2/3 of his bar. Mantis has 1/6 of her bar. Gamora has 3/8 of her bar. And Drax has 1/4 of his bar left over. So all I've done here is represent those bars of chocolate with bar models. What I'd like you to do is find out how much chocolate the following combinations have together. So if you're going for the mild challenge this week, I'd like you to first work out how much chocolate does Drax and Peter have all together. Then I want you to work out how much does Rocket and Peter have all together. And then I want you to work out how much does Groot and Mantis have all together. If you're going for the spicy challenge, I'd like you to work out how much does Rocket and Gamora have all together. What about Peter and Gamora? And then Rocket and Groot. And finally, if you're going for the extra hot challenge this week, can you work out how much Drax and Mantis have all together, how much Peter and Groot have all together, and how much Gamora and Mantis have all together? So once again, I'd like you to pause the video for 10 minutes or so. I'd like you to use whatever resources you have available to you. You might have fraction cards or strips of paper, and I'd like you to use bar models to help you work out how much each of these combinations have altogether. It's time to reflect on what we've learned today, so once again I want you to pause the video for a few minutes, and with a partner I want you to discuss the following questions. What have you learned today? What did you find easy or difficult? Did you get stuck? What helped you when something got tricky? What do you need more help with? What is really making you think? And what are your next steps? The last thing I'd like you to do today is apply what we've learned. So as a class, I'd like you to analyse and solve the following problem. Groot and Rocket are racing to the top of the mountain. Groot has climbed 1 3/4 miles so far. He's still got 7/8 of a mile to go. What is the total distance from the base to the top of the mountain? And once you've had a go at that, I'd like you to consider the following. Rocket has climbed 2/3 of a mile so far. How far ahead is Groot? Thanks for joining me again today. I hope you enjoyed that. Remember, you can contact me at scott.morrow@southayrshire.gov.uk if you've got any questions about today's lesson. You can follow me on Twitter at scottmorrowsa, where you can find my weekly Friday Maths challenges, and you'll find all my videos available at Scott Morrow Maths on YouTube. Next week, we're continuing to focus on fractions, and we'll be trying to work out a fraction of an amount. I hope you can join me then.